Okay, ladies and gentlemen, let's take a look at some of our problems from page 317. Now, number one says cotangent of theta is 5/7. But if I look over here, I see that cotangent equals 1 over tangent. So if I have 1 over tangent theta equals 1 over 5/7, then that allows me to flip both of these and turn this into 7 over 5. So if this and this are reciprocals, then the answers are reciprocal, so 7/5. Now, on the other hand, if cosine x equals 1/6, then sine x equals root 35 over 6, find cotangent. Well, that's adjacent, that is hypotenuse, that is opposite, that is hypotenuse. I'm going to draw a picture. My adjacent side is going to be 1. My opposite side is going to be, since this is positive, going up. So I got positive, I got root 35, I got 1, I got 6. At this point, I now have a picture and can say cotangent, and it's adjacent over opposite. So adjacent over opposite would be 1 over 6. There you go. Now, again, the key there is just draw the picture by labeling and determining positives and negatives. So find the value of the expression using the given information. If you have secant theta and cosine theta, I won't find secant theta and cosine theta, knowing that tangent is negative 5 over 1, and cosine of theta is greater than 0, so that has to be positive. So if cosine has to be positive, that means the adjacent has to be over here, so we're either in 1 or 4. And then, since tangent is negative 5 over 1, that makes the opposite negative and the adjacent positive. So I got 1. I got negative 5. At this point, I can find the hypotenuse. So I can say 1 squared plus negative 5 squared equals 26 and square root both sides. So square root 26. There you go. So secant is hypotenuse over adjacent. So secant is root 26 over 1, and cosine is 1 over root 26. So again, it's simply a matter of drawing the pictures. Draw the pictures. Okay, so if I move on down here, now this one becomes a little bit more challenging. We say, whoa, secant of theta minus pi over 2. This is going to be some kind of a function. Well, let's see here. I have a property right here that says cosecant equals secant of pi over 2 minus theta. So that would be super awesome if this were pi over 2 minus theta, because then I could just say, oh, well, whatever this is, that's what this is. But that's not true, because we have theta minus pi over 2. This is pi over 2 minus theta. So what I need to do is I need to turn these around. So to make secant, well, here, let's make it over here, secant. And if I want to turn this around, I would say negative 1 times theta. Well, here, let's get some more paper. I'm running out of space. Here we go. So we have secant theta minus pi over 2. I need a pi over 2 minus theta. So here's what I'm going to do. I'm going to take out a negative 1. So I have secant parenthesis negative 1 parenthesis pi over 2 minus theta. That would allow me to turn it around. Now, I have a negative 1 inside a secant. So if I come over here and I say, ooh, secant with a negative inside, means if secant a negative inside is the same thing as secant with no negative. So the basis of odd-even functions, in an odd function, the negative that's inside comes out to the front. And so in an even function, the negative that's inside just goes away. Just like if I have negative 2 cubed, that's an odd function, I get negative 8. But if I get negative 2 squared, even function, it goes away and it makes positive 4. So in this case, the negative that's inside of the secant can just go away, and we can treat it just like it were secant theta. So this negative 1, because secant is an even function, because it's based off of cosine, the negative goes away. So I can say that if cosecant of theta equals negative 1.24, then the secant of theta minus pi over 2 is also negative 1.24. These are the same because the negative went away. If, on the other hand,